law. Errors are most frequent during requirements and design activities and are more expensive the later uh, they are removed. What this means in practice: relative cost of an error depending on when it is discovered. In x-axis project phase, y-axis cost, in x-axis requirements, design, code, unit test, system test, field or project phases. In y-axis cost, 0, 50, 100, 150, 200, 250, 300 and so on so on. So here requirement start, design, then cost also increase using step by step. After before field system test, then cost reached maximum. Waterfall model advantages, already we have seen in the last videos. Uh, uh, there some of the major disadvantages: simple and easy to understand and use, easy to manage due to the rigidity of the model. Each phase has specific deliverables and a review process. Phases are processed and complete one at a time. Um, Works well for smaller projects where requirements are very well understood. Clearly defined stages, well understood milestones, easy to arrange tasks, process and results are well documented. Waterfall model having the following disadvantages. They are: no working software is produced until late during the life cycle, high amounts of risk and uncertainty. Next, not a good model for complex and object oriented projects, poor model for long and ongoing projects, not suitable for the projects where requirements are at a moderate to high risk of changing. So, risk and uncertainty is high with this process model. It is difficult to measure progress within stages, cannot accommodate changing requirements. Adjusting scope during the life cycle can end a project. Integration is done as a big bang at the very end, which doesn't allow identifying any technological or business bottleneck or challenge early. In the iterative model, iterative process starts with a simple implementation of a small set of the software requirements and iteratively enhances the evolving versions until the complete system is implemented and ready to be deployed. An iterative lifecycle model does not attempt to start with a full specification of requirements. Instead, development begins by specifying and implementing just part of the software, which is then reviewed to identify further requirements. This process is then repeated, producing a new version of the software at the end of each iteration of the model. Iterative model design. Iterative process start with a simple implementation of a subset of the software requirements and iteratively enhances the evolving versions until the full system is implemented. At each iteration, design modifications are made and new functional capabilities are added. The basic idea behind this method is to develop a system through repeated cycle, iterative and in smaller portions at a time, incremental. The following illustration is a representation of the iterative and incremental method. So, iterative model system is created by successive versions. Go through each process step, then iterate, similar to how you are taught to write paper. Include feedback between steps. Lowers the cost of implementing requirements changes. Allow allow some client user feedback to be considered. Smallest sized steps means the delivery of something comes sooner. Value is created earlier. It may not be clear where in the program the project is. Changes can lead to messy designs and implementation. Feasibility analysis, specification, requirements, architecture, design, and then development, code, validation, test plan, then evaluation maintenance, then again feasibility. During each iteration, here the development module goes through the requirements, design, implementation, and testing phases. Each subsequent release of the model adds a function to the previous release. The process continues till the complete system is ready as per the requirement. The key to a successful use of an iterative software development lifecycle is rigorous validation of requirements and verification and the testing of each version of the software against those requirements within each cycle of the model. As the software evolves through successive cycles, tests must be repeated and extended to verify each version of the software. Then iterative model application. Like other SDLC models, iterative and incremental development has some specific applications in the software industry. This model is most often used in the following scenarios. Requirements of the complete system are clearly defined and understood. Major requirements must be defined, however, some functionalities are requested. Enhancements may evolve with time. There are time to the market constraints. A new technology is being used and is being learned by the development team while working on the project. Resources with the needed skill sets are not available and are planned to the uh, pla- to be used on contract basis for specific iterations. There are some high risk features and goals which may change in the future. Okay. In the iterative model, pros and cons. The advantage of this model uh, is that there is a working model of the system at a very early stage of development, which makes it easier to find functional or design flows. Finding issues at an early stage of development enables to take corrective measures in a limited budget. The disadvantage with the SDLC model is that it is applicable only to large and bulky software development projects. This is because it is hard to break a small software system into further small serviceable uh, increments modules. The disadvantages of the iterative and incremental SDLC models are as follows. Some working functionality can be developed quickly and early in the life cycle. Results are obtained early and periodically. Parallel development can be planned. Progress can be measured. Less costly to change the scope requirements. Testing and debugging during a smaller iteration is easy. Risks are identified and resolved during iteration, and each iteration is an easily managed milestone. Easier to manage risk, high risk part is done first. With every increment, operational product is delivered. Issues, changes, and risk identified from each increment can be utilized applied to the next increment. Risk analysis is better. It supports changing requirements. Initial operating times is less, better suited for large and mission critical projects. During the life cycle, software is produced yearly, which facilitates customer evaluation and feedback. So, here, so actually again the disadvantage of the iterative and the incremental SDLC model are as yeah, more resource may be required. Although cost of change is lesser, but is not very suitable for changing the requirement. More management attention is required. System architecture, uh, system architecture or design issues may arise because not all requirements are gathered in beginning of the entire life cycle. Defining increments may require a definition of the complete system, not suitable for smaller projects. Management completely is complexity is more, management complexity is more. End of project may not be known, uh, which is a risk. Highly skilled resources are required for risk analysis. uh, Highly skilled resources are required for risk analysis. Project progress is highly dependent upon the risk analysis phase. Before individuals and interaction over process and tools working under here. This is a response to our CLS and the right process monitoring working software over comprehensive documentation. Customer collaboration over contract negotiation, responding to change over following a plan. Uh, that is where there is value in the items and the left more. There is response to overzealous and right process mongering. Emphasis getting to the right result versus creating a lot of useless documents or planning, blindly following process. However, this is not a reproduction of documents or plans. Agile is a set of SDLC approaches. Uh, Here, Agile, under here, Scrum, Crystal, Kanban, XP, DSDM, FDD, RVP. Yes, this ranges is there. glossary